biasing. Okay, so today we'll learn how to deal with when AC is applied. Okay, how to analyze transistor signal. So basically AC analysis means here AC small signal analysis. Okay, small signal AC analysis. Okay, and there are two models. Okay, so while doing AC analysis, for a small signal, we have to replace, okay, transistor by its equivalent model. Okay, so there are two models. One is called RE model, transistor, and the second is your hybrid equivalent model, hybrid equivalent model. Okay, so we will do only this model, RE model. Okay, because your exams questions mainly are asked on this, based on this RE model. So before I discuss this model, okay, this model means whenever you will use AC, a small signal AC source, okay, and you want to amplify this, the main use of transistor is amplification. So whenever I want to amplify some signal, okay, on those questions I have to replace transistor by a, whether it is a common base transistor, okay, or common emitter configuration transistor. So I need to replace it by some model, equivalent model. Okay, so whenever, so amplifier, okay, so whenever we discuss amplifier, there are important parameters which where we are, in which we are interested. Okay, so important parameters. So for example, I have a two-port system, or say amplifier. This is my amplifier. Okay, it may be BJT or anything else. Okay, BJT, FET, anything. So it has a two inputs and two outputs. Okay, so here I will apply input voltage, input current will flow IE. Okay, and here I will measure V output and mention my I naught current like this. Okay, output current. So here I will measure. So there are four parameters I need to measure. One is input impedance. Okay, input impedance. Input impedance, this ZI, that is equals to VI upon I. Okay. The next is output impedance. Okay, output impedance is mentioned by Z naught, that is equals to V naught upon I naught. The third parameter is voltage gain. When you're using amplifier, what is voltage gain? That is your V input upon V input. Okay, VI. What is the input here? Okay, there may be another source here. So what is input here? What is output here? Okay, the ratio of these two things will give you the gain. And the last is your current gain. That is your I naught upon I in. Okay, so we are interested in these four parameters. Now I'll take first common base configuration and I will replace it by a equivalent model. So for example, I have a PNP transistor, common base. This is common base. Okay, these are my input terminals and this is my output terminal. So If it is PNP transistor, current will go like this. Okay, so say this is my ammeter and this is my collector. Obviously this is base, which is grounded. So here I will apply some voltage. Okay, so this is my E, this is VB. So VB will be your V input here. Okay, and similarly here you can measure V naught. Okay, so this is your PNP transistor. Now I want to replace, IC is coming, I is coming here. Now I want to replace this transistor for AC signal. Okay, so if AC signal is there, how can I replace this transistor? Okay, so you know this is my this is like a diode. Okay, this is like a diode. So if I want to replace this transistor at input it is junction, so I can replace this by a diode. Okay, so I'm applying VB voltage and I is current flowing here, and here is what IC is what. So you know in common base configuration your IC is the thing that is the alpha IE. This is the input current, this is the output current. Okay, so here you have current, so this I can replace by a current source. Okay, I want to isolate the input from output. Okay, so this is your basically, and this time current is going upward, so put it upward. This is alpha IE, which is equal to IC, and this is going here. Okay, so basically this is your model. Okay, this is, just give me 1 minute. So this is NPN or PNP. So this is for PNP. For PNP. So whenever you see transistor, okay, so of course there will be input resistance and there will be output resistance also. So let me modify this equivalent circuit a little bit more. So you know whenever you are applying AC signal to a diode can be replaced by a resistance. We already discussed, and we were discussing a small signal analysis of diode. I told you diode can be replaced by RE, where RE value is what? RE value is what? What is the value of RE? Alpha IE, and that here I can put a output resistance, say R naught. Okay, what is the value of RE? Have you done have we done this before or not? We replace this diode, okay, by resistance in a small signal AC analysis. Then what was the value of RE? No one attended the classes, that class. So that RE is basically equal to your 26 millivolt upon IE. Okay. Now let me summarize you this, what we are doing here. So whenever if you see a transistor, okay, so while doing AC analysis, okay, what I will do, I will replace this transistor. This transistor has a two part, one is the input part and output part. Okay, I'm isolating this transistor, so I'm making an equivalent model. Okay, so this transistor can be replaced by an input. This is a diode, and diode can be replaced by a resistance. Okay, so this is my input part. This is a common base PNP transistor. So common base transistor can be replaced by this equivalent circuit. Here you have a current. Okay, alpha is a current gain. So this is the input current. I is input current. Okay, IC is output current, and your alpha is the current gain in common base transistor. So alpha is your current gain, which value is almost equals to 1. Okay. Now suppose if this is an NPN transistor, then you can replace the polarities. So if this is an NPN transistor, okay, then the current direction will be like this outside. So this will be your IE going here, IC will be coming here. Okay, and this will be replaced by like this. Okay, and current this will be coming here. So this will be equal to this one, and this will be opposite. Okay, IC will be coming here. So this is the equivalent model for NPN transistor. So this is common base NPN transistor. So you have to remember this model. Any question? No, nobody is asking anything. Okay, it seems nobody understanding anything. Huh?
सर आउटपुट पार्ट का नहीं आ रहा, उसमें डाइट क्यों नहीं कंसीडर किया?
आउटपुट नहीं, ये वाला
हाँ जी सर।
भी इनपुट ट्रांजिस्टर में क्या होता है? इनपुट रेजिस्टेंस तो आउटपुट रेजिस्टेंस भी होता है ना?
यस सर।
So output resistance generally we say very high. When we have seen output characteristics, output resistance was almost infinite. Okay, so if I say R0, this output resistance infinite, I can make it open. Okay, but I'm assuming this output resistance I0 is very high. So whenever question it will say infinite, I will remove this one. Okay, so now here you have current is coming like IE. Okay, so IE, so this is a diode, so I have replaced this by diode. Okay, output you are getting what? You are only getting current, which is a multiplication of this one. Okay, so I have taken multiplication of this current, like alpha E is current. So output you can output here this current, input have this current. Okay, this is
इन आउटपुट देयर इज आल्सो अ डायोड ना, मतलब वो बेस और इमिटर को कलेक्टर का होगा।
हाँ, पर हमको इक्विवेलेंट मॉडल बनाना है ना भी। हमको आईसी बेसिकली, हमको तो आईसी चाहिए। आईसी इज बेसिकली व्हाट? डिपेंडेंट ऑन दिस वन ना। IC basically dependent on this one. So once we know IE, okay, तो इसको कैलकुलेट करने के लिए हमको किसी और चीज की जरूरत नहीं है। we can simply multiply by alpha IE. That's why we're not putting it transistor here. Okay, so your RE model is basically equals to RE model is basically equivalent to what? It is the equivalent to in diode in input. Okay, diode plus a current source at output. Okay, so this is sufficient to show the characteristics of this one. Okay, now if you know INE, you automatically know IC, so you know everything by knowing this model. Okay, this will be clear when we'll solve the problem. This picture will be clear what we are doing. Okay, now this was common base configuration. The most important thing which we are interested, or we are going to use this your common ammeter configuration. Okay, so we are interested in common ammeter configuration. So in common ammeter configuration, you have this one. So you're grounded. And this is your, okay, or you can say this is your output, and this is your input, and this is your ground. Okay, now again say NPN transistor. So this will be like this. Okay, and here I'm applying some V input, which obviously will be, now this case this will be VBE. Okay, because we're using AC, so I'm using the symbol small symbols. Okay, so this will be your IB is coming here. Okay, IB, say IB, IC is coming here. Okay, IC, and then your IE is coming here. Now this transistor again I want to replace by equivalent model. So equivalent model again, this will be replaced by transistor. Okay, a diode. So you have a diode like this. Okay, IB is coming, and you're applying VBE. Then along with diode, there we have a current also coming, current source. Okay, that is your beta IB. Okay, so this is your basically equivalent model. Okay, so either you can replace by this model, okay, or you say no, I want to isolate this input and output. That also we can do. So first of thing, this also can be replaced. I have a IB, and this transistor I can replace model, this diode I can replace by resistance as usual. What we do, RE, okay, VB and IB is coming, okay, and there is again source. So equivalent of this will be what? So equivalent of this one be, you have a source beta IB, and then you have this one IB, IB, and here you're coming beta IB, IC is coming, okay, and this current is your IE. Okay, this current is coming through this one, which is resistance. This is your IE. Okay, so this current is combining. Now I can replace this by resistance, that is RE, and I can say I current is flowing through this resistance, and this again can be separated out. Now यहाँ पे I करंट प्लॉट कर रहा है, ओके, यहाँ पे IB कर रहा है और यहाँ पे IC कर रहा है. Now what I want to do, I want to isolate this input from output like we have done earlier. Okay, so we know my IE is what? My IE is my beta plus 1 IB. Okay, or I can also write, if beta is greater than 1, I can write IE equals to almost beta IB. Okay, so the voltage VB here, that becomes beta IB RE. Okay, but I want to isolate this IE. Okay, I want to make it IB. So this can be converted to IB by simply writing RE, change RE to beta RE. Okay, and then VBI, you have IB. Okay, and this is again separate, and this is again isolated or separated out. This become your beta IB. This can make ground. So this is IC coming here. So this is the equivalent circuit of this one. Okay, now you can see nothing changed. If I replace RE by beta RE, okay, nothing is changed, because ultimately the voltage here VBI is what? IE-RE. So VBI is basically IE-RE, which is equals to beta IB-RE. Okay, and if you see here, what is VBI here also? Here also VBI your beta RE IB. So VBI input voltage is not changing here. Whatever voltage is here, same voltage is here. Okay, I have just replaced this RE by beta RE. Okay, so that now I can say confidently this current, this IB current is flowing here. Okay, and this is the, so once I know this base current, automatically I know this output current IC, and here your IC is related by IB with beta IB. So this is the equivalent model for your common emitter transistor. Okay, this point is clear? Anyone in doubt how I'm writing from here, how I'm coming from here to here? This current I is what? This combination of IC and IB. Okay, so I have just replaced this IE by beta plus 1 IB, beta IB. Okay, now I want just to flow this current IB in this resistance. So I have multiplied this RE by this beta. This has become my now equivalent model for transistor. Okay, but itna hi yaad karna hai, only just you to remember that this you have to replace by this one, and the rest is calculation is same what we are doing earlier. Okay, and if you want to put here output effect, you can put a resistance R naught also here. This is the equivalent model. Okay, shall I erase this one? So let me demonstrate this thing with a problem. Small signal AC analysis. Okay. Number one, step one. Okay, steps. Number one is apply the DC analysis. Okay, or perform the DC analysis. Apply the DC analysis. Okay, replace capacitors by open circuits. Okay. Number two, okay, for the AC analysis, okay, short the power supplies. Okay, that is for the AC analysis, DC power supply will be turned off. DC power supply will be turned off. Okay. Number third point, okay, redraw the simplified circuit. Redraw the simplified circuit. Okay. Number point 4 is, okay, replace transistor by equivalent model, equivalent RE model. And the last step is do AC analysis. Okay. Now, what does mean of these steps? लिख लिया सब ये?
सर एक मिनट.
So AC analysis include your DC analysis also. So जैसे हमने DC में किया था, the way we have done DC, okay, because if you want to replace by transistor by a equivalent model, so of course you need RE, and RE you cannot calculate unless you don't do a DC analysis. So wherever you want to, you will get a amplifier circuit. Okay, first you need to solve it for DC. Okay, so that you should know IE. You don't need complete analysis, but you need to calculate IE. Once you know IE, you can calculate the RE. Okay, and then you can come to the AC analysis. So see, you have been given a circuit like this. Let's see. So I'm using the simplest circuit, okay, fixed bias circuit. So this is RB. Here I'm applying VCC, okay, and here you have a capacitors, and here you have a V input. Here you have capacitors, and you have V input here. Okay, so V output basically you're taking here between these 2 points, and this is your V input. So here you are applying some signal and you are getting your amplification V naught. Okay, now so I need to solve this circuit. So here IB current is coming. Okay, this is your IE current. If I do DC analysis, IB, and this is your IC. Now, first step is understanding. First step number 1. Okay, DC analysis. Okay, so DC analysis is simple. If DC is flowing, this circuit will be like an open circuit. Capacitor will be open. Okay, and now you can perform your DC analysis. You can calculate the IE. Okay, the aim of DC analysis is calculate IE. Okay, so IE you can calculate how, if you know the IB. Okay, IB, and if the beta is given, you can calculate what is IE. So the first aim is to calculate IE. Okay, now once you have calculated IE, the step 1 is completed. Now step 2. Step 2 is, what is step 2? What was step 2?
AC analysis.
AC analysis में क्या करना है? Step 2 में लिखा है, what is step 2?
DC power को turn off कर.
DC, you turn off DC powers. Okay, turn off DC power means you make it grounded. Okay, and this will be your short circuited. Capacitor will be short circuited. That you can note here. Okay, the short circuit capacitors and turned off VCC. So now you have, second step is completed. Okay, first step is as usual. Second step is just you make it ground. Now the third step is you make the simplified circuit. Okay, so let me now make a third, the simplified circuit. So how can I simplify this circuit? It is very easy. Okay, now you know this resistance is between base and ground. So instead of writing, I can break this. Okay, so this is also grounded, this is also grounded. So I can break this one. So this is grounded. Okay, so instead of drawing like here, I can draw it to a nice way. Okay, so I can draw here V input, and RB I can make it ulta, opposite. This is your RB. Okay, and this is grounded, and this is RB is one part is grounded, other part is going to VB. Okay, so transistor. So this is my transistor, and then you have RC also. So RC also going where? RC also going, one part is capacitor, the other is going to ground. So RC also you can write like this. This is your RC. Okay, and here current is coming. So here current is going IC. Here you don't know actually what is the current. If there is no division, you write I naught here. Okay, if some division is there, then you can write like this. Okay, so this is your RC. Okay, here current going IC, and here current going I naught. I don't know what is the resistance here, output resistance, and this is grounded. So this is grounded. Okay, so in particular case, I naught is equal to IC. Okay, in particular case, this is I naught equal to IC, but is not always true. We'll see that one. Okay, so this is your basically simplified circuit. Now your circuit becomes simplified, and V naught you're taking across and the IC, same, the V naught is same here. So this is your simplified circuit. Okay, just I have reversed this one, because all become grounded once we make power supply 0. All become grounded. So I have just made reverse this one. Okay, so it looks very simple circuit now. Okay, now the step 4 is what? Step 4 is replace transistor by a, okay, equivalent model. Step 4, replace by equivalent model, replace by equivalent model. Okay, so you have V input, you have RB, okay, then your transistor, and transistor can be replaced by a resistance simply. It's really very simple. Once you replace by resistance, the कहानी खत्म हो गई. Okay, and you know here V input is there. This is giving a I input current here, and here the current which flowing should be IB. Okay, IB, and here you have a RB resistance. Okay, and then you have to make output. Output is simply your beta IB. Okay, and if you want, you can put a output resistance here, say R0. So I have replaced transistor by a equivalent model. Okay,
सर
and then
RC नहीं लिखेंगे सर?
लिखेंगे ना. And then you have here, say RC. You have here RC. Okay, this is, if you want separately, you can make this is ground. This is ground, and this is also ground. And RC, I told the current is flowing I0. Okay, here current is flowing IC. This is beta IB is equal to IC. We don't know what is current here. Okay, I know total current which coming from this branch is IC, and current flowing here I know that only I know. Okay, so, and this is my input. So this is input circuit, and this is my output circuit. Okay, now once you know this circuit, now you can perform what you know. You want to calculate amplifier. Okay, so you want to calculate input impedance and output impedance, the 4 parameter which we have mentioned in the beginning, that you want to calculate. Okay, so let me first calculate input impedance. Okay, so for this circuit, what is the input impedance? So input impedance, number 1 parameter, input impedance. So input impedance is nothing, JI equals to VI upon II, isn't it? Okay, and VI is equals to what? This VI equals to voltage here, and voltage equals to here, and here voltage was what? VB. Okay, so VI is nothing, is equals to VB, and VB is equal to nothing, is IBRE. Okay, and I input. What is I input? How can I find I input? So
IB plus जो resistance RB से flow करेगा current.
Okay.
VI upon RB plus IB.
How can I write? See, total current is I, and the current and current going here. So I can use current division technique, na? Current division technique. Once I know this technique, okay. So suppose I want to know what is the current here, RE. So how do I write? Suppose I want to write IB. So IB will be total current is IE, and if I want current in this resistance, I have to take this resistance RB. Okay, and I have to take total resistance RB plus RE. Can I write like this? IB like this? ऐसे लिख सकते हैं क्या? Tell me. Just give me 1 minute. Okay. Are you getting this one? This thing you're getting or not getting? Tell me. This thing. This part is clear or not clear? I want IB. IB is here. Total current IE. I want what is the current IE flowing here? That is, I can apply current division there, two resistance only. Okay. This is the isolated. So total current is coming. This total current. I want current and this resistance. I can add this resistance upon total resistance. So I know IB. Okay. From here I can calculate the IE value. This give me IE is value what? RB plus RE upon RB. Okay. Now you know VI, you know II. Calculate your Z impedance. So Z impedance will be your VI, IB, RE. Okay, and II is your IB, RB plus RE into IB upon RB. Okay, this cancel out. So ZI become what? RE, RB, RB, RI. That is parallel combination of RE into RB. RB. This is your input resistance. Okay. So input resistance is what? What is the resistance between these two terminals? So I can see easily only these two resistors are connected across this terminal. What is the Z Thevenin? R Thevenin. R Thevenin is what? These two resistors are parallel. So this is only Z impedance. The terminal, the input impedance is what? The resistance that the input impedance is called your input resistance. Okay. So input resistance is nothing. These two resistance. So that's we are getting RE parallel RB. That's it. So we can just see and tell what is the your impedance. Okay. Clear है कि नहीं है? If you have doubt, please ask. If anyone is not understanding, please ask. Okay. So this is your input impedance. Okay. Now let me write the next parameter. Okay. You have to remember this one. That is RE plus RB. Now if I say RB is greater than RE, okay, or RB is greater than at least 10 RE, then this is a parallel combination. So only RE will dominate. So I can simply write RE ZI, the input impedance is just equal to my RE. Okay. So once you become habitual, this become very easy. This is very easy. This is not tough thing. Okay. Once you do 2-3 problems now, then you will understand what method is there. Okay. So that is RE. Now the next thing is you want to calculate your I naught, Z naught output impedance. Okay. Next thing is output impedance. Okay. Output impedance is nothing, that is your Z naught, and Z naught is equal to here. So this is my V naught. Okay. And your Z naught is simply your I naught RC. Okay. And I'm measuring the output like this, but this current is going opposite. Current should come down. Okay. So I can simply write this is my I naught RC. Okay. So V naught. So this is V naught. V naught equals to minus Z naught IC. Okay. Now you want Z naught. Z naught is nothing. V naught upon I naught. Okay. So what I can write now? I don't know this I naught value. Okay. I want to bring this I naught value in terms of IC. So I can write this term is coming here and some current is going also here. Combine this, they form IC. Okay. So the reverse will be, if I do current division, then I can find what is my I naught. So I naught is total current is IC. Okay. Total current is IC. And then if I want current in this branch, I have to take resistance of this one R naught, and total resistance R naught plus RC. Okay. So my output impedance, okay, Z naught will be what? V naught. V naught is my I naught RC. Okay. And then I naught. I naught is this. IC R naught. Sorry. What is I naught? I naught is just this one. So IC R naught.
replace.
हाँ ये सही है क्या?
रिप्लेस
ऊपर वाले में भी रिप्लेस करना पड़ेगा आई नोट को, तो
आई
फिर
नोट तो कैंसिल ही हो जाएगा, बस आरसी बच
आरसी बचेगा खाली। जेड तो आरसी पर इस रेजिस्टेंस का फायदा क्या हुआ फिर? इसका रेजिस्टेंस का क्या फायदा हुआ? जस्ट 1 मिनट। Okay. So I forgot to tell you. Okay, how to calculate the output impedance. So whenever I want the impedance across this terminal, okay, I need to make other sources shut down. So I need to make this current source. I need to make this open. Okay, I need to make this open. I forgot. Okay. Now the input impedance. Okay, input impedance here. Okay, simply the parallel sum of this one. So your this will be your just R naught RC. Okay, and if I say that your R naught is greater than RC, okay, in that case your Z naught will come just RC. Okay, so your input impedance is just RE and your Z naught is just RC. Correct. This is just RC. The next thing is I want voltage gain. Okay, voltage gain. So voltage gain is represented by AB voltage gain, that is equals to V naught upon Vi. Okay, so V input we already seen. This is a IBRE. Okay, and V output just now I told you that is minus I naught RC. Okay, so put the values, and I naught you bring in terms of IB. So I naught was equals to just now I written IB. This is, if this is IC, sorry, this is your, now this is your beta IB. Okay, so and this is IC. So I naught is just IC into what I can write, resistance of R naught here, and total resistance R naught plus RC. Okay, and this is your beta IB R naught. Okay, R naught plus RC. Just to put the values and take the ratio. Tell me what is coming. So V naught is your minus ICRC, and your V input is your this IBRE. Okay, and I naught I will written in terms of IC. IC is your beta IB. IC is your beta IB. So tell me what is coming.
minus beta RC R naught.
Minus beta
RC R naught.
minus beta IB नहीं आ रहा क्या?
अभी तो
कैंसिल हो गया. RC R naught upon
RE divided by RC plus R naught.
RC
plus R naught.
ऐसा आ रहा है
सर RD से मल्टीप्लाई, ये ब्रैकेट में आएगा RC plus R.
अच्छा, so RE RC plus R naught ये आ रहा है.
यस सर.
ऊपर R naught आ रहा है.
यस
तो
सर.
ऊपर आरसी नहीं आ रहा, आरसी
नहीं, ऊपर तो RC आएगा. ये कैसे आ जाएगा? ये कैसे हो गया? आपका V आउटपुट तो दे रखा है ये वाला, जस्ट नाउ मैंने लिखा है V आउटपुट आपका क्या है? V आउटपुट इज योर बीटा IB R naught. Okay, R naught plus RC. Okay,
आरएस
और बीटा या वीबीआई वो क्या है? वीबीआई आपका जस्ट नाउ मैंने लिखा बीटा बीटा, कोई बीटा नहीं, आई बी आर ई। ओके, तो आई बी कैंसिल हो गया, तो इसको कैसे ले सकते हैं आप? आर नॉट, ठीक है, इसको और सिंप्लीफाई करना पड़ेगा। सो ए वी is equals to beta r naught re r naught plus rc. So
आरसी आ रहा है ना?
हाँ?
आरसी आ रहा है सर, आरसी।
का ऊपर rc आ रहा है?
हाँ जी सर।
कैसे?
सर आईसीआरसी था ना वो, आई नोट आरसी।
ठीक है,
वी
और माइनस भी आ रहा है ना?
यस सर।
ठीक है, अब तो आ गया। सो अब क्या हो जाएगा? दिस इज r naught rc, r naught plus rc, so this become what? Minus beta, this become r naught parallel to rc upon re av। यही फॉर्मूला है आपका वोल्टेज गेन का। ओके, and now if you say if r naught is greater than rc, in that case your voltage gain will become simply minus beta rc upon re, small re, small re। सो अब कल करेंगे इसको, ठीक है? थोड़ा सा तुम लोगों के दिमाग में जाए पहले से एक बार, मजा नहीं आ रहा अभी, ठीक है? सो टाइम भी हो गया, सो थोड़ा सा इसको देखना है, व्हाट हैव यू डन टुडे, just go through that and tomorrow we'll do again. Okay, it's very easy. Once we एक बार हो जाएगा तो आपको आसान लगेगा। So I'm stopping here. We'll meet after 5 minutes. Digital class.
Thank you, sir.